Welcome, dear students, to the course of Advanced Algorithm Analysis. This is week number 7 of the course, and in this week, we will cover selection sort algorithm, its dry run, and also its analysis. If you remember, let me recap what we have studied in the previous week. In week number 6, we talked about the bubble sort algorithm. I emphasizes on the technique that the bubble sort used to sort the data. In the introduction, I shared with you that it is one of the oldest and simplest sorting algorithm. Simplest in the sense that bubble sort is simple to understand and also simple to implement. Similarly, the technique used by bubble sort algorithm to sort out the data is also very simple. However, from the running time of the bubble sort algorithm, we observed that bubble sort algorithm is not an efficient algorithm, especially for sorting the large data. How it works? In bubble sort, we take the element at the first position and compare it with the element at the second position. If they are out of order, we exchange them, swap them, and then the process continue till the end of the array. So it means that bubble sort algorithm actually makes a number of passes through the list of elements, and on each pass it compare the adjacent elements. If they are out of order, they are swapped, and the algorithm repeats this process until no swaps are needed, which indicate that the list has been sorted. Bubble sort algorithm is known as comparison based sorting algorithm because the main function or the main activity of the algorithm is the comparison of two adjacent elements. And it has different steps. In step number 1, like for example, the first two element at location 1 and element at location 2, they are arranged such that a1 is less than a2, and then we compare a2 and a3. If they are out of order, they are bring into the appropriate order, that is a2 is less than a3, and then a3 and a4, and then a4 and a5. Finally, an minus 1 is compared with an, and they are bring into the appropriate order. So which it means that in step 1 of the bubble sort algorithm, we actually perform n minus 1 comparison. And bubble sort algorithm is called bubble sort because at the end of each step, one of the element is bubbled out to the nth position. Similarly, the process repeated in step number 2. However, now we have to perform one less comparison in step number 2 because one of the element has already been sorted out. And then we perform rest of the steps. We also goes through the bubble sort algorithm. We also performed dry run over the bubble sort algorithm, and finally we have seen the analysis of the bubble sort algorithm. Especially we concentrated on two cases. There is the worst case. In this case, we considered that the array which is given to us is in a reverse order. That is, if we want to sort the array in ascending order, then the array given is in descending order. And in the worst case, the running time of the bubble sort algorithm was n square, or you can say big O n square. Similarly, we have seen the best case analysis of the bubble sort algorithm. Best case mean that the array given is already in sorted form. And in that case, we have seen that the time complexity of the bubble sort algorithm in best case is big O n, or you can say n. It is a linear function. Okay, so in today's lecture, we will discuss another sorting algorithm, which is called the selection sort. We will start with the introduction of the algorithm, then we will see some examples and the technique used by the selection sort algorithm to sort out the data. And finally, we will move towards the analysis of the selection sort algorithm. So here is the contents at a glance. We will be starting as usual with the objectives. What we expect at the end of this lecture. So at the end of this lecture, the student will be able to understand the theoretical aspect of the selection sort algorithm, the algorithm itself for the selection sort, and finally, we will analyze the running time of the selection sort algorithm. More specifically, we will be concentrating on the worst case analysis of the selection sort algorithm. So we will start with the introduction, some general examples, and then the algorithm and analysis of the selection sort algorithm. So let us see the introduction of this algorithm. Selection sort, like the bubble sort algorithm, is also a comparison-based sorting algorithm. What does it mean? Any algorithm that is based on comparison actually compare the elements with one another in order to sort out the list. Or you can say that the main activity of the comparison-based sorting algorithm is the comparison of the elements with one another so that they are bring into a logical order. The logical order can be ascending order or it can be descending order. Remember that like the bubble sort algorithm, selection sort algorithm is also inefficient on large list. That is, you can use them for sorting small data set, but however, if you have thousands of elements to be sorted out, then in that case, the running time is going to be larger. As we will see in the analysis, it has a running time of n square. And in the running time of algorithms, I shared with you that the algorithms whose running time is n square, it grows very rapidly with the size of the input. As it depends on the size of the input, then if we provide a large input size, then the running time is going to be increased very rapidly. So that is why it is inefficient on large lists. However, like the bubble sort, it is also a simple sorting algorithm. By simple, we mean that the concept of this algorithm is very simple to understand. As it is based on comparison, so we have to compare the elements. Which element we need to compare, that is we are going to explore in a moment, but the technique used is simple. It is simple to understand, it is simple to calculate the running time of this algorithm, and finally it is simple to implement the concept of the selection sort algorithm. Now the question is that how selection sort actually sort out the data. Every algorithm that we used for sorting actually uses a different technique, a different mechanism to sort out the data. Like we see, we have already observed that the technique used by insertion sort was different from the technique used by the bubble sort. And now we will see that the technique used by the selection sort is actually different from the bubble sort as well as from the insertion sort. Later on, we will study more sorting algorithms like merge sort, quick sort, etc. And there we will observe that these the technique used by those algorithms will be different from selection sort, from bubble sort, and from insertion sort algorithm. So every algorithm uses a different technique, a different approach towards the data. Remember, in the beginning of this course, I told you that for a single problem, we can actually have multiple solutions. And this is the job of the analysis of algorithm or the design of the algorithm, that we have to select the best solution among them. So we have a problem to sort out the data. And for solving that problem, we actually have multiple solutions available in the form of different algorithms. and the technique used by each and every algorithm is actually different. So coming back to the question, how selection sort actually sort out the data, or how this algorithm works. So the technique is very simple. The first thing you need to do is to find the minimum value in the list. You will be provided with the data, with a list of data, items of data, elements of data, and they are going to be in unsorted form. Your job is to sort them out by using selection sort algorithm. So when you apply the selection sort algorithm, the first thing you need to do is to find the minimum value in the list. Once you find the minimum value in the list, the next step is that exchange this value or swap this value or interchange this value with the element at the first location. And then finally you have to repeat this process, finding the minimum value and swapping it with the element at the first location. You have to repeat the process for the remainder of the list. However, this time you have to start from the second position element, because at the end of this swapping process, actually you will see that one element will be in sorted form, so you do not need to consider it again for the process. So you have to repeat the process starting from the second position element and then advancing each time. For example, in the next step, you have to start from the element at the third position and then element at the fourth position and so on. So this is the basic technique. Let me repeat. The first thing is that you have to find the minimum value in the list. Once you find the minimum value, you have to swap it with the element at the first position and then repeat the same process for the rest of the elements starting from the second position. Selection sort algorithm, if you think on the technique, it actually divided the list into two parts. Or you can say the list is divided into two sublists. One sublist will contain the items that are already in sorted form, which is built from left to right or at the beginning, and the second sublist of items will contain the remaining elements that need to be sorted out. You can say one of the sublist is in sorted form while the second sublist is in unsorted form, right? So this is a technical point about the selection sort, that actually it will divide the given list into two sublists. One list will be in sorted form while the second list will be in unsorted sublist will be in unsorted form. At the beginning of the selection sort process, the sorted sublist will be empty, and then gradually we will be adding element to the sorted array, and finally at the end of the selection sort, the elements or the sublist of the unsorted element will be empty because all data will be in sorted form. So at the beginning of the selection sort, the first sublist will be empty, while at the end of the selection sort, the second sublist will become empty. How it works? Let us understand with a simple example, a simple demonstration. Here we have a list of elements which are in unsorted form. So the list has 7 elements starting from 0. You can actually start the index with 0 or 1, it depends on you. Normally we prefer to start it with 1 in case of algorithms, but if you want to implement them, then you have to start it from the indexes from the 0. Okay, so we have a data which is given by this 76, 67, 36, 55, 23, 14 and 6. So we have 7 elements which is in unsorted form. These two are variables. We will use them we when we study the actual algorithm of the selection sort algorithm of the selection sort process. But for here, I is actually a loop variable which will count the number of passes. So initially we have 0 passes over the data, then pass number 1, pass number 2, 3, 4, and then 5. Total number of passes like the bubble sort is n minus 1. And this is another variable which will actually help us in finding out the location at which the smallest animal the smallest animal is available. So here if you see at the list, the smallest element is 6 and its position is 6, so minimum position is 6 here. Similarly in this list is, if you give attention, then the smallest element is 14 and it is present at the position 5. So here the variable contain the 5. Okay guys, so the first thing that we need to do in the selection sort algorithm is to find the minimum value in the list. So if you see, the minimum value is 6. Okay, we have find the minimum value. What next? Now you have to swap this element with the element at the first location. So first location is represented by 0 here. So exchange these two values. 6 will take place of 76, while 76 will move to the location 6. Now at the end of this pass, we have one element in the sorted form while remaining elements are in unsorted form. And you see the list has been divided into two sublists, right? So at the end of one pass, we have one element in sorted form while the remaining elements are still in unsorted form. Now you have to repeat the same process for the rest of the elements. You don't need to consider the first element because it is in sorted form now. So do not compare it with other elements now. Move on. Now take the rest of the elements, find the minimum value. So here the minimum value is 14. Select it and swap it with the element at the second location that is being represented by 1 and swap them. So after swapping, 14 will take the place of 67 while 67 will move to the location where 14 was previously saved. Now two elements are in sorted form, remaining elements are still in unsorted form, right? Again, apply the same process, repeat the same process, find the minimum value in the list, in the remaining list, or in the unsorted sublist. So if you see now, in this list, the smallest value is 23, which is at the position 4. Select it and swap it with element at the third location represented by 2. So swap them. 23 will take the location of 36 and 36 will move to the place where 23 was previously saved. Now we have 3 elements in sorted form. The remaining list is still in unsorted form. What you need to do now is to find the minimum value in the second sublist or the sublist of unsorted elements. So giving attention, we come to know that now the smallest element here is 36 and its location is 4. So once you have find the minimum value, you have to swap it with the element at this location, that is 55. So 36 will take the place of 55 and 55 will take the place of 36. So now we have exchanged these two elements. Repeat the same process. You see now we have 4 elements in sorted form, remaining element are still in unsorted form. Repeat the same process, find the minimum value here. So here the minimum value is 55. Okay, now we have a different situation. Actually in the remaining list, the minimum value is already in the appropriate location. So you do not need to perform the sweep operation here. It is a point for MCQ. You may be asked in the paper about this MCQ that in the selection sort algorithm, do we need to sweep an element if it is already in its appropriate location? So the answer is false. We do not need to sweep it with any element. So it will maintain its own place. Now we have 5 elements in sorted form and 2 elements are in unsorted form. Again, repeat the same process. Find the minimum value in these 2 elements. So as you see, the minimum value is 67, which is already in the appropriate location, so there is no need to sweep. And once you have left with one single element, so we know that single element is already in sorted form, we do not need to sweep it or compare it, so our algorithm finishes here. If you see, one of the drawback of this algorithm is that actually our list is in sorted form. Just have a look on this pass for 6, 14, 23, 36, 55, 67, 76. But still the algorithm doesn't stop here. It continue till the end. So we don't know what element we have at the next location. So even though our data is already in sorted form, it will continue the process until we reaches the end of the algorithm. So this was the basic technique of a selection sort algorithm. Technically, we can say that we have an array and the elements of the array are like a up to n. If you start from 0, then the elements are going to be from 0 to n minus 1. So depending on the indexes, whether you are starting from 0 or from 1. So the selection sort algorithm worked as we saw that first we start by scanning the entire list to find the smallest value, and once we find the smallest value, we have to exchange it with the element at the first location. What we'll do, or what we will achieve at the end of this step, actually putting the smallest value, it will put the smallest value in the final position in the sorted list. So again, I am going to stress that we need to find the minimum element in the list, and then at the end of the first page, the smallest element will occupy its location, that is A1 or A0 depending on the indexes. Then we have to scan the list again, but this time starting with the second element, finding the smallest element in the remaining n-1 elements, and then exchange it with the element at the second position. Actually, at the end of this pass, the second smallest element will be in its appropriate position, that is A2. And then you have to repeat the process, continue this way until the second largest element is stored in the second final position. So after performing n-1 passes over the data, you will see that the list will be in sorted form. Let us see a more detailed example to understand better the concept of selection sort algorithm. Okay guys, so consider an array having these elements in unsorted form. You can see that the first element is 7, and then we need to find the smallest value in this list. Once we find the smallest value, we need to sweep it with the element at the first location. So for that, the first element, namely 7, is compared with all other elements starting from 1. So compare 7 with the 1. After comparison, we observe that 1 is smaller than 7. So they need to be swept. So 1 will take the location of 7 and 7 will take the location of 1, as you can see here. Now the same process is repeated until the element at the first position is compared with all other elements. So now you have to compare 1 with the second element, that is 5. So 1 is already less than 5, so there is no need to swap them out. Compare it with the third element now. Compare it with the 4. Again, 1 is less, so there is no need to swap them. Now compare it with 9. Again, 1 is less than 9, so there is going to be no swap. They will maintain their location. And then you have to compare it with the 2. Again, 1 is less than 2, so there is no need to swap them out. And then you have to compare it with 3, and then 10, then 8, and then 6. So after one iteration, the smallest element will comes at the first position. So this is actually one pass, or you can say one iteration or one step of the algorithm. And at the end of this step, one element will move to the appropriate location, that is the first position. So now we have one element in sorted form while remaining elements are in unsorted form. The list has been divided into two parts. One sublist contains the elements that are in sorted form, while the second sublist contains the elements that are in unsorted form. So at the end of first phase, only one element is in sorted form, while the remaining elements are still in unsorted form. To sort them out, we have to move forward. This time we need to start from the second element because the first element is already in sorted form. Repeat the same process. Compare the element at the second location with all the elements one by one so that we can find the minimum value. So compare 7 with 5. Okay. From here we can see that 5 is less than 7. So they need to be swept. So 5 will come to the location of 7 while 7 will move to the location of 5. Now you have to compare 5 with the next element, that is 4. And after comparison, we come to know that 4 is actually less than 5. So they need to be swept out. So now 4 will come to the location of 5 while 5 will move to the location of 4. Okay, again compare it with the next element, that is 9. So 4 is already less than 9, so there is no need to swap them out. Okay, now compare it with the next element, that is 2. After comparison, we came to know that 2 is actually less than 4, so there is a need to swap them out. So 2 will take the location of 4 and 4 will take the location of 2. Okay, now we have the 2 at the second location. Repeat the process, compare it with the next element, that is 3. So 2 is already less than 3, so there is no need to swap. Compare it with the next element, that is 10. 2 is already less than 10. Now compare it with the next element, that is 8. 2 is less than 8. And finally compare it with the last element, that is 6. So 2 is less than 6 as well. Now this is the second iteration. In the second iteration, the second smallest element comes at the second position. Now we have 2 elements in the sorted sublist while 8 elements in the unsorted list. What we need to do now is to repeat the same process for the element at the third position. Now we need to find out the smallest element in the remaining unsorted list. For that, we have to compare them and swap them if necessary. So from here, I think, yes. So from here you have to take the element at the third location, that is 5. Actually, one of the step has done directly. 5 is they have swapped 5 with 7 like this. So compare them. 5 is already less than 7, so they will maintain its location. Then compare it with the next element, that is 9, already less, so no need to swap. Compare it with 4. 4 is less than 5, so we need to swap them out. Now compare it with 3. 3 is less than 4, so we need to swap them out. Now compare it with the next element, that is 10. 3 is already less, no need to swap. Compare it with 8. 3 is already less, no need to swap. Compare it with the final element, that is 6. 3 is already less than 6, so there is no need to swap. At the end of third iteration, the third smallest element has been found out and it is moved to the correct location. Now our first sublist contains 3 elements which are in sorted form, while the remaining elements are still in unsorted form. Okay, now continue in the same way. Take the element at the fourth location, compare it with the next element. After comparison, we came to know that they are already in sorted form, so there is no need to swap. Compare it with the next element. Okay, 5 is less than 7, swap them out. 7 will be interchanged with 5. Now compare 5 with 4. 4 is also less than 5, so swap them out. Now compare 4 with 10, no need to swap. Compare 4 with 8, again no need to swap. And now compare it with 6, no need to swap. So now we have 4 elements in sorted form while the remaining elements are still in unsorted form. And then we have to continue for the next iteration. The fifth element will be in the sorted, will take its appropriate location and then it will be sorted out. The process will continue in a similar way for the sixth iteration, then for the seventh iteration, and then for the remaining position. At iteration number 9, the 9th smallest element will be placed at the appropriate location, and the last element is already in sorted form, so we don't need to perform the 10th iteration. So if you have 10 elements, the total number of iterations are going to be 9, because the iteration would not be needed for the 10th element, because the only remaining element is already in sorted form. So in each iteration, the smallest element from amongst the unsorted element is found and placed at its proper or appropriate location or position. So let me repeat that the algorithm selects the smallest value in each iteration. Therefore, it is called selection sort algorithm. If you remember, bubble sort algorithm is called bubble sort because at the end of each pass, one of the element is bubbled out to the appropriate location. Selection sort algorithm is called selection sort because at each pass we actually try to find the smallest value in the list, or you can say the smallest value is selected in each pass. That is why it is called selection algorithm, selection sort. Okay. One more thing that which is related with the implementation. You can implement the selection sort algorithm by using different methods. The method that we are going to use is actually based on iteration, and we will see that the running time is going to be n square. However, you can also implement the selection sort algorithm with the help of divide and conquer approach. We do not studied it yet. Hopefully in the coming week we will discuss the divide and conquer approach in much more detail, because some of the algorithms, they are based on the divide and conquer approach. For example, the merge sort algorithm is actually based on the divide and conquer approach, and similarly quick sort algorithm, if I'm not wrong, is also based on the divide and conquer approach. And that is the best suitable approach for sorting out the data, because we will see in the couple of weeks that the divide and conquer approach algorithm actually have the running time of n log n, which is very much efficient for large data. Okay guys, so let us see one more example of the selection sort algorithm. The purpose of showing you this example is to let you know that there are different ways or different flavors of the selection sort algorithm. The examples that we just seen, we select the minimum value and then we swap it with the element at the first location, then at the second and third. However, you can also implement this algorithm in another way. Instead of finding the smallest value, you can actually find the largest value as well. However, in that case, you have to move the value to the final position, to the last location, instead of moving it to the first position. So here is an example. We have given an array or list of item which is in unsorted form, and our task is to sort them out by using the selection sort algorithm or selection sort process. In this example, different colors are used. For comparison, light yellow color; for data movement or sweep, light green color, and the blue color to represent the sub list that has already been sorted. So first thing first, what we need to do is to start comparing the elements. So first we need to take the element which is at the first location and then compare it with the second element. So 5 is greater than 1. Okay, there is no need. Remember, this algorithm works from the other side, so we are interested in finding the largest element instead of finding the smallest value, right? So 5 is greater than 1, so there is no need to swap. Again, take the next element, compare it with 5. Again, 5 is greater than 3, so there is no need to swap. Move on to the next element, there is 4. Compare it with 5. 5 is already greater, so there is no need to swap them out. Move to the next element, there is 6. Again, you see, here we found the largest element. Now 6 is greater than 5. Okay, but move on. Now 2. So now 2 is less than 6. Okay, so in the first pass, we actually find the largest value. You will be imagine how or where this largest value was stored. We will see it in a moment that actually the algorithm uses a variable, and that variable actually contain the current largest value. For example, at the beginning of this pass, the largest value was pointing to 5, and then we were comparing it one by one with other locations. Soon when it catches 6 and it finds that 6 is greater than 5, so the largest will now point to 6. So this is actually a variable which will contain the largest value that we encounter during the comparison process. Once you find the largest value, the second thing we need to do is to swap them. Okay, as I told you that we are working from the other side, so we have to swap it with the element at the last location, not at the first location. So 6 will be swapped with 2, and now one element is in sorted form. The blue color represents the sorted sub array. So at the end of first pass, one element is bring into sorted form. Remaining elements are still in unsorted form. What we need to do? We have to repeat the same process again for the rest of the element. So starting with the first element, that is 5, take the first element or element at the first position, Compare it with the second element, that is 1. 5 is greater than 1. Okay. So now the largest is currently pointing to 5. Move on. 3. Again, the largest is 5 because 5 is greater than 3. Move on. Compare 5 with 4. Again, 5 is greater than 4. Move on. That is 2. Again, 5 is greater than 2. So we have find the largest in the remaining unsorted list. So largest will point to 5. In this unsorted list, in this remaining unsorted elements, the largest value is 5. So we have to swap it with the element at the second last position. So swap it with 2 and that's it. Okay, at the end of second pass, the second largest element was moved to the appropriate location. Now we have 2 elements in sorted form and the remaining 4 elements are still in unsorted form. You can see that the selection sort actually divided the array into 2 subparts. One subportion already sorted form, the second still in unsorted form. Again, repeat the process for the third step. Starting from the first element, compare it with the second element. Okay, so now our largest is pointing to the first element because 2 is greater than 1. Compare it with 3. Okay, now here after comparison we came to know that 3 is actually greater than 2. So our largest will point to 3. Move on. Okay, compare 4 with 3. Okay, 4 is greater than 3 as well. Good. So the largest will point to 4. Our largest value is now here. 4 is the largest value in the remaining unsorted list. Okay, so now you have to swap it with the element at the first position. Sorry, do not need to swap because it is already in the sorted form as we are considering the largest element. So now we have 3 elements in the sorted form and 3 elements in the unsorted form. Repeat the same process again for the rest of the 3 elements. Starting from the first element, compare it with the element at the second position. After comparison, we came to know that the largest is still at the first position. Move on. Okay, 3 is now the largest. So once you find the largest element, you have to move it to the appropriate location. But 3 is already in the appropriate location. So at the end of step number 4, actually 4 elements are bring to sorted form while remaining 2 elements are still in unsorted form. Repeat the same process. Take the first element, compare it with the element at the second position. After comparison, we came to know that 2 is actually the largest element. So swap them with 1 and that's it. Done. So total of 6 elements, we need 5 steps to be performed over the data, and then the list is converted into sorted form. So you can see you can implement selection sort algorithm either by searching for the smallest value or searching for the largest value. If you are using the smallest value as your main technique, then you have to swap the element with the starting from the first element. However, if you are selecting or going for finding the largest value, then you have to swap the element at the element with the element at the final or the last location. So there is the difference between the two implementation, and you can also implement it by using the divide and conquer approach, which is going to be the topic of our next week. Finally, to better understand the idea of selection sort algorithm, we have an animated or dancing video as we saw in the case of bubble sort algorithm. So we have a very interesting video about the selection sort algorithm. So let's have a look over the video to understand selection sort and how it works. Here we go. Actually, I do not want to interrupt the video, but let me uh, tell you what's happening here. Actually, we are searching for the smallest value, and then once we find it, we have to swap it out with the element at the first location. So carry on. Okay, guys, so one element is in sorted form, that is 0, smallest value. Now again, we have to repeat the process starting from the second element. Okay, currently we are looking for the smallest value and we are comparing it one by one with the rest of the elements. So 1 is compared with 3, then 8, then 7, and then it will be compared with 2 in dancing style. Okay, as you can see, 1 is the smallest, so there is no swap is actually happening here because 1 is in the appropriate location or the proper location position. So swapping is not possible, but comparison, of course, we have to compare because we do not know where another value, smallest value lie. So the process continue till we reach to the end of the array. Okay, after final comparison, we come to know that actually 1 is the smallest value. So it will take its position. Repeat the process now for the next element. Compare it one by one with the rest of the elements. Okay, a swap happened. You see, 2 is less than 3, so they swap their positions. Okay, so this is going to be the last comparison. between the elements. He's so excited, by the way. Okay, so the list is finally in sorted form. She feels lonely. That's why she come to the front. So it was about a selection sort algorithm and how it works with the help of an animation. Okay guys, so this was about selection sort algorithm. Let us take a break. In the second half of today's lecture, we will talk more about the selection sort algorithm. We will give a dry run to the algorithm, and finally we will see the analysis of selection sort algorithm. See you then. Goodbye.